Hello students, welcome to Sarasa classes, and the question here is the compounds which gives benzoic acid on oxidation with KMnO4. Theory over here is toluene, okay, spelling I got wrong, toluene or its derivatives, okay, such as other alkyl benzenes, okay, with minimum one CH atom attached to the phenyl group, isn't it, will undergo oxidation by KMnO4 to form benzoic acid. Okay, now if you have a close watch at the compounds given out here to us, which are as follows. See, there is a H out here. So, and this particular carbon is directly attached to the phenyl group. So, obviously, we will say this will give benzoic acid on oxidation. All right, with KMnO4. For the next one, however, if we check, then we find that this carbon is joined to three carbons. So, obviously, this will not undergo oxidation. All right. For the next one, we have a biphenyl type of system. Okay, we have a biphenyl type of system, and which is obviously having this carbon is having the H. Obviously, then we will say this will undergo oxidation by the KMnO4 reagent. Okay, and after acidic workup. So this is my first reagent, and that is my second reagent. And the product I will get out here, you know, even after it is going oxidation, but this is not your benzoic acid. Okay, your benzoic acid basically is this. Now here we have say KMnO4. Question is not that whether it is undergoing reaction with KMnO4. They have said it should form benzoic acid as the product. So that is the reason we have to negate option C also. Now for option D, as we can see out here, it is going to fulfill the criteria. Yes, it is having H out here. So obviously this also will undergo oxidation with KMnO4. They need to do the acidic workup, and we will say that this is going to give us the desired benzoic acid as the product. Okay, I hope that clarifies the question that we had. That means our answers here are going to be D and A. Okay, now in the next question that was asked, all right, so it has been given the products P and Q formed in the reaction. We have been given a trans butene out here. Okay, and it is mentioning that this particular CFCl is in singlet state. Now, for make you to understand what is the picture of a triplet and a singlet. So this is your triplet. Why we're calling it a triplet? Because it is having two unpaired electrons. Now, why we're calling it a singlet? Because it is having paired electrons. Okay, so its multiplicity is going to be, if we calculate 2s plus 1, it is going to be, if we say 2s plus 1, so s out here is going to be 2 into 0, 1, so it is going to be 1, and here if we do 2s plus 1, s out here is going to be 1 plus half, that is going to be 1, so it is 2 into 1 plus 1, that is going to 3. That is why it is called a, this is called a triplet and this is called a singlet. Now, keeping this thing in mind, if we draw the molecule like this, so there can be another arrangement wherein we can have this type of a orientation, and these additions, if we call them as stereospecific, okay, the orientation of the initial reactants will decide the kind of products we will get. So this is also having two paired electrons. So let's consider that here, okay, this is combining with that and that is combining with that. So we can have a formation of a cycle, and okay, so under this requirement, okay, we will say that if one of the methyls is over here, say like that, the left hand one is on the top, then the right hand one is going to be downwards, and obviously keeping that in mind, we will say the Cl is going to be up and the F is going to be downwards. So these are our methyls. What will be the other product? Obviously we will say now the F is going to be on the top. This methyl is on the top, that methyl is downwards. Similarly, this Cl is now downwards. Okay. All right. Had this been a triplet, then what would have happened is that after combination with one of these electrons, suppose this electron is combining with that electron, okay, what would have happened? We would have had a intermediate that could undergo CC bond rotation. But when we are having a singlet, okay, there is no possibility of CC bond rotation. That is, this particular bond will not rotate. Okay. Okay, the intermediate that is formed will not undergo any CC bond rotation. Here there is no question of intermediate, it is happening in a single shot, but in a triplet state there can be a possibility of an intermediate which can undergo CC bond rotation. So it will not be stereospecific, okay, but this is stereospecific. And if we compare the answers, obviously we will say our answers are going to be over here. Our answers are going to be over here, B. All right. Our answers are going to be over here, B. So that is going to be our answer. All right. So thanks for listening. Have a great day.